For more information, please visit SGMAC Associates website.
Hi, I'm going to, this part of the lecture, I'm going to discuss the 6 factors, economic factors that we'll be using to solve cash flow problems. The general thought of solving these problems are from problem statement, you go to cash flow diagram. And from after you having drawn the cash flow diagram, you move the cash flows to typically to a present point in time or a future, or sometimes an arbitrary point in time in the planning horizon. You move them through proper discounting, and in that process you got to use appropriate factors. That's important. So for example, what I mentioned here, look at the factor F over PIN. It estimates the future value of $1 after n periods, where each period earns an interest rate I. So the factor, interest rate per period, and number of periods. Following the same reasoning, P over FIN is the present sum of money that will have a future value of $1 after n periods. So each period earns an interest rate of I. So P over FIN, F over PIN, the simplest way to remember which factor to use, you look for what's given and what you're trying to find out. What's given will go in the denominator. What you're trying to find out will go in the numerator. So F over P, if I'm given P, I have to find F, then I'm going to use the factor F over P because P is given, is in the denominator. I want to find the future value of some present value P, so I'll use the factor F over P. P over F, given the future value, what is the present value? So what's given is in the denominator. What's given is in the denominator. What you need to find out will be in the numerator. That is easy to remember. A over PIN, one set of factors that we'll be using, is called the capital recovery factor, and is used to calculate the annuity to repay a loan. You'll be using that a lot. In this case, P is given. A simple example will be the some amount you have borrowed from the bank. That's your P. You'll repay it in annuity payment, A, equal end of period payments. So in this case, you're trying to find out, given P, what's the value of A? How do I repay a loan in n payments when I'm paying interest rate I in each period? So that's called capital recovery from the bank's point of view, how the bank recovers money that you have borrowed from the bank. Okay, a reciprocal depending on the need. You can convert an annuity to a present value by using the factor P over AIN. Okay, other factor that we'll be using is A over FIN and F over AIN. The same way, again, the rule is the same. A over FIN, you can take a future value and you can convert it into annuity. Certain amount of money, n periods in the future, what's the equivalent annual amount out of that for each period if you want to find out. So depending on the problem, different factors you have to bring up and use it. Each factor on the right, what I've mentioned here, the 3 of them on the right, can be estimated a reciprocal of the factor on the left. So they are related. So if you know F over PIN, if you do the reciprocal, you get the factor P over FIN. Same goes with other factors. Okay, so you have to be conversant with of using these 6 factors. And there is another factor we'll talk about, which is called when you have a gradient series. We'll come and talk about that. But these 6 are the most commonly used. So it's very important that you recognize Again, as the factor indicates, first recognize which factor to use. You know the rules. What's given in the denominator, what you need to find out goes in the numerator. That gives you the factor. Then be very careful about how many periods you're dealing with. Your period could be day, week, month, year, and a high interest rate should be compatible with each time period. So typical example will be monthly payment. You repay mortgage or car loan every month, so your interest rate comes out to be every month in that case. But if it's in weekly basis, then interest rate should reflect per interest rate per week. Number of periods should reflect how many weeks you're talking about. So thus I'll keep cautioning you throughout the semester about these few simple rules that you need to remember as you solve the problems. Moving on. So let's look at this. We are not interested in derivation of these factors, but some of them will be helpful, just how they look like. For example, if you want to find the future value of a present sum P after one time period, all that I'm doing is I'm adding the interest P times I to the principal. So the future value after one time period will be the principal amount plus the interest amount. So it will be P plus P times I, or P multiplied by 1 plus I. So in two time periods, now if you take two time periods into future, then the value that you have, the future value that you just computed end of period 1 becomes the present value that you move into one time period. So F2 becomes 1 plus I squared. So F3 after 3 time periods, where each time period is giving you interest of I, the future value will be P times 1 plus I raised to the power 3. So following that, after n time periods, F will be P times 1 plus I raised to the power n. So F over P factor is 1 plus I raised to the power n. That's how the factor comes. Now remember, you don't have to, it's good to understand this simple formulas, but important thing is you don't have to memorize them. I will not ask you to derive it. And they are in the form of lookup tables. So you'll retrieve factors F over P I n once you know I and n from appropriate tables. So for example, here if interest rate is 1% per period, and if you want to find the future value after 360 periods, 30 years, if your period is a month, then the F over P, that factor is 35.95. That means $1 invested today at the rate I, at 1% per period, after 360 periods, it will be multiplied by almost 36 times. $1 will grow into $35.95 at the end of 360 periods. The time period could be day, week, month, or year. And as I said again, interest rate and time period should be compatible. That's one thing you need to be clear about. That some problem will do where you have a mixed time period. You're putting in cash every month. You're depositing cash every month, but maybe you're taking out every quarter. So in that case, you've got a two separate set of cash flow. Time buckets are different, and we got to use the appropriate interest rate depending on what time bucket we are using. Okay, when you solve problem, it will be a little more clear. So that's the rationale for computing factor F over P. A over P IN is called the capital recovery factor. As I mentioned before, you'll be using it given P, you want to find A. So in this case, what happens is you have borrowed some money, you want to find out how much annuity payment you got to pay if you decide to pay over n time periods. Again, you're not responsible for derivation, but just look at a simple equation here. If you look at the cash flow diagram, you have borrowed money, that's the benefit you got, P, and your A is cost from your outflow, P is your inflow, and all A's are your outflow in this case. All those end of period payments, if you take them to the present, they'll have a present value equal P, the money that you have borrowed. Okay. So the second and third diagram that I've drawn, you can think from the bank's point of view. Bank has given outflow of P, given the money that has gone out of bank, and A is annuity payment coming back to bank every end of every period. Okay, so cash flow diagram, most of the time we'll be drawing for you. So what it shows that it will have it simply changes direction, arrows changes direction when you go from a loaner to the creditor. Bank, the last two diagrams are for the bank, the first one is for the creditor for you. So what you're doing here, we are taking the individual cash flow and moving them to the present value. So the first cash flow is one time periods in future. So if you divide by 1 plus I get the corresponding present value of that future value. The cash flow that's 2 time periods away in the future, if I want to get the present value of that, so it will be A divided by 1 plus I squared. As you can see, as you go more into future, the corresponding present value becomes smaller because it has more time to grow. So that's what you're doing for individual cash flow. We are finding the present value of that. The first one I divide by 1 plus I, second one 2 time periods away, 1 plus I squared, and the one that's n time periods away, 1 plus I raised to the power n. If I add it up, that should be equal to P, and that gives you the factor P over A is this geometric series. Now, I think I have shown a little bit of this derivation. You have done geometric series in the algebra, basic algebra, and this is how you sum up a geometric series. Again, you are not responsible for the derivation, but it's good to understand what you are doing here. So we are summing a geometric series. This geometric series, if you take two consecutive terms, their ratio stays the same. So second term over first term will have the ratio which will be same as fourth term over third term, or nth term divided by n minus first term. Two consecutive terms have the same ratio. Okay. There's the signature for, geometric series. So then I have shown a summation, but as you can see, the factor P over A is 1 plus I raised to the power n minus 1, I times 1 plus I raised to the power n. I'll post a page, I don't think I've done it yet. I'll post a page in Moodle where all these factors, these expressions will be there. And so most of the time, almost every time you solve a problem, the factor will come from the table. But if for some reason you don't get a table for a particular interest rate, then you got to do a longhand calculation. Especially if you're doing during the test, you got to go back to the basic equation and find out P over A. Let's say P over A where I is not given in the tables that you have. So that's where you got to keep those factors. I'll post a page where all 6 factors corresponding equations are there. And actually you need only 3 because you take the reciprocal to get the corresponding other factor. So if you have the expression for f over p, we compute that, and then if you need p over a, just take the reciprocal. Alright, so that's how we compute P over A or A over B, capital recovery factor. Again, no need to memorize it. Don't need to memorize it. Let's just see how it is, how we derived it and be able to use it. Moving on, here's a particular problem. I think that this part of the course, economic analysis, will look at a lot of problems, how they are solved, because that's how, like I keep saying, there are not too many fundamental principles for this part of the course. So we'll just fold them into different problems and bring them out again and again. So in this case, let's look at the problem statement. This is just a capital recovery factor we just talked about. You have borrowed $300,000 from bank at 4% annual percentage rate. Amount borrowed is $300,000 at 4% annual percentage rate, compounded monthly. So we'll talk about another slide how to compute the interest rate. So in this case, pay attention to the terms 4% APR, and then you are given a compounding frequency. If nothing is stated, the compounding frequency is 1. We are talking about end of year interest payment. In this case, you are paying every month. So compounded monthly, so you got 12 compounding period in a year. So that's the interest rate. So basically you're paying 4 over 12 or 1/3% every month. You borrowed, your plan is 30-year fixed rate plan. That means you'll make $360 end of month payment. Your rate is fixed next 30 years. If you don't want to change, there are sometimes you're given an opportunity to change the amount if the interest rate changes, especially if it drops. Otherwise, your annuity payment stays the same. This may be viewed as a typical loan for $330,000 house, 10% down payment. Now, some of you have already maybe a purchased house. If not, you'll do it soon. The common rule is, whatever the price of the house, you make 10% down payment, and remaining you borrow from the bank. So you can think about a purchased house for $330,000. So $30,000 you're paying somehow, and remaining $300,000 you're borrowing from the bank. And we are interested about the money that you have borrowed, how you're repaying it. So the interest rate is 4 over 12. Why 12? Because it's compounding monthly. There are 12 compounding periods in a year. So in this case, what we're interested in is to find out A given P. What's my annuity payment? What's given is in the denominator, what you try to find out is in the numerator. So factor A over P at 1/3% and 360 payment, and that number comes out to be now I have just computed it as at 1/3% using because there's no table for 1/3%. So you go back to the equation and plug in value for I and N. So this number is 0.00475. So monthly payment is $1,425. So you have borrowed, you want to purchase a house for $330,000. You have made 10% down payment, and remaining amount, the money borrowed, you want to repay in 360 end of month payment, equal amount annuity payment, and that amount is $1,425. Okay, so that's just a simple application of this is a capital recovery factor. Application of capital recovery factor. It also shows that I computed by looking at the expression for A over P, because 1/3% is not readily available in the table. Here's an expression for factor F over A. All that you're doing is, in this case, in P over A, you are moving them into the present. In F over A, you take the annuity payment and move them into the future. Okay. Hi, we are posting materials online. If you have any doubts or any questions uh, regarding the materials posted, feel free to get in touch with us through email. Um, Provide your name, address, school name, your contact information. We also welcome if you provide comments so that things can be improved upon. We also appreciate if you provide any feedback. Okay, so let us know what do you think about the material posted. Okay, bye now.
For more information, please visit SGMAC Associates website. For more information, please visit SGMAC Associates website. For more information, please visit SGMAC Associates website.